Okay, we're going to look at interfacing sensors to a PLC, and I have two sensors that we're going to use to do this. One of the sensors is a capacitive PNP sensor or sourcing sensor, and I've used this in a previous video. And the other sensor is an inductive NPN or syncing sensor. So we have a sourcing sensor, capacitive, and a syncing sensor, inductive. And we're going to show how to hook this up to our PLC here. Now, one of the things that's you need to keep in mind is this PLC may not be the same as the PLC you have, but pretty much the interfacing is all the same between PLCs. Okay, so this PLC, like any PLC, has the capability of having input cards, and I have an input card here, and this input card is a syncing or sourcing input card. So it allows syncing or sourcing inputs to drive the input card. I also have an output card here, and what I've done is written a simple program that simply transfers any change of state on the first input of this card and activates the output on the syncing output of this card. So this card is a DC syncing card. But all I'm really doing right now to make sure my program's working correctly and everything is looking at the indicator light for the port that I want to activate. And we're using port 0 on the output card. We're going to activate that when we get an activation on port 0 on the input card. So very simple program. And if you had a spare PLC, you could write one to test your interfacing for a sensor. One of the important things about this is to get familiar with the sensor before you actually implement it in design. So one way to do that is just play with it. Hook it up to a power source, watch what it does, get it to drive some sort of device like an LED is always a good choice. Now let's look at the setup right here for this PLC. This is a Moacon PLC. It's sold by a company called Comfile Technologies. And you can find them at www.qblock.com. QBlock is one of the products that they sell. The way I've got this configured right now is this is just my programming cable that hooks to my PLC, and this just uses a USB cable that has a type B output on it on this side and a type A on the other side of the cable. This is a type A USB connector. Okay, and then this is just my power supply. All I've really done here is I've got a wall transformer that provides one of these that provides 24 volts. And the nice thing about this PLC is there's several ways to power it. One way is through this coax connector. If you have a 24 volt power supply that uses a coax connector, you can plug it in right there. Okay, so this is a close-up of the connection to the PLC that you would normally use to power this up. And so we have a 24 volt and ground for your input to the PLC, and then we have 5 volts and ground that are available for whatever other circuitry you want to power that needs 5 volts. So this is available for an output. This is a 10 slot rack system right here. The first slot is always for the CPU, and the rest of the slots are for input and output cards. And you can get a variety of cards for this particular PLC, analog inputs, timers, all different types of cards that I'll show in a later video. So right now all I need to do what I'm doing here though is I need an input card and I need an output card. And I put two little pieces of metal in the common and input 0 on the input card, so I can show you how you can drive this with both a positive or negative signal relative to common. First, to look at the input capabilities for this card, the fact that it can use either a syncing input or a sourcing input, I've just got two 9-volt batteries hooked in series. This provides 18 volts, which is more than enough drive for the input card, and I've got it hooked to these connectors here. And so what we're going to do first is do what most people would try to do initially, is we're going to hook common to negative, and we're going to hook the input card, the input port on card 1, and notice that we have the input card lighting up. That's letting us know that there's an input there, and the output card is lighting up, letting us know that our program is transferring the state of the input from the input card to the output card. So you can see that lighting up. I'm going to zoom in a little bit on that, a little bit better. And so activating my input with a 18-volt signal, we see that everything's working fine there. Now I'm going to reverse the polarity, and ordinarily you might think this would be destructive, but no, this card is designed to handle that. So whether my input is negative or positive on the input card, I can light up my output. And as I said earlier, that's because this particular card is a syncing or sourcing input card. It allows both types of sensors to be hooked to it. Now the way you hook them up to the input card, whether it's a syncing or sourcing input, is a little different, and we'll go into the details of how to do that. Okay, the first thing you want to do is get familiar with your input card and get some specifications on it. So I pulled up the specifications on this input card. This is an 8-port digital input module, and it provides inputs in 2 groups of 4. And if you notice here on the side, it shows that the polarity doesn't really matter, because this will handle both syncing and sourcing inputs. So if our polarity is positive in to the input, that's okay, and if it's negative in to the input, that's okay. And both of those are relative to common. So this is broken up into 4 inputs and a common, and 4 more inputs and a common, and these are separated from each other, these sets of inputs, these groups of 4 inputs. Inside the PLC input card is an optical isolator, and this optical isolator is a bidirectional optical isolator, which means that it can handle current in both directions. So when we hook our syncing or sourcing inputs to the card, the first thing you want to do is make a schematic of how you want the current flow to work in this particular application here. So the way this particular optical isolation system works is if we provide a positive to the input on this card and we hook the negative to ground, then when we activate the switch, we will turn on the LED on the right. And when that LED turns on, it sends a light beam to a phototransistor, and that's all part of the internal circuitry of the input card. And this does a couple of things. For one thing, it simplifies the interfacing for the PLC, but it also provides optical isolation, which means that any sort of catastrophic problem on the input is not going to propagate into the PLC itself. The worst case scenario is you're going to have to replace the input card. Now if we were to reverse the polarity here and apply our negative input to our switching device and our positive to common, then when we press the button or we activate the sensor, then we turn on the LED on the left, and this provides light to the phototransistor too. So either way, whether your polarity is positive on the input or negative on the input relative to common, you're going to get an activation on your input card. The first thing we want to do to hook up the PNP capacitive sensor is to look at a little drawing of what's going on with the switch, the sensor, and the input card. So here I have a little drawing of the sensor, and this is just a model of what the sensor is doing. There's a switch up here. It's not a mechanical switch, it's a PNP transistor, and when that PNP transistor is activated, the output terminal is pulled to V+, or it's sourced. Now we want to be able to hook that up to our input of our card, and the way we need to do this is we want a complete circuit when we make this hookup. So one thing we do know we want to be able to do is hook our input to our output of our sensor. So let's go ahead and make that connection. So there we have the output of our sensor hooked to the input of our card. Now remember, the card has an optical isolator in it, and one of these 2 LEDs is going to light up when we complete the circuit inside the input card. Since the input of the input card is going to V plus, it means the common on the input card has to go to V minus to complete the circuit. So once we make that connection, then we have a complete circuit here when the switch closes. And under those conditions, this doesn't really matter as far as the overall scheme of things. But what's really happening here is when we close this switch, we forward bias this diode right here, and that diode provides light for the phototransistor inside the input card and activates the card. And we've got a complete circuit here because we're bringing in V plus into here, through this LED, out this way, back to V minus. So the common in this case has to be hooked to V minus. It's better to look at something like this, a diagram, than it is to just come up with some rules of thumb on how to hook these up, because you really need to understand what's going on in order to ensure you don't have any problems with this, or in order to fix problems that you might have. So here we have everything hooked up to the PLC the way it's supposed to be hooked up. I have V minus right here hooked to the common, and I have power, V minus power, coming in off my battery to the common. Remember, we said that the common on the PLC had to be hooked to V minus for this particular sensor that we're using right now. Then we have the input from the sensor, the black wire, hooked to the input 0, and we have V plus just going to the sensor to provide power to the sensor. So with this connection, we ought to be able to activate the input to the sensor, and you can see the input light coming on and the output light coming on. So the input light's telling us that the input is getting the proper signal from the sensor, and the output light is just basically telling us that the PLC program is processing that input appropriately. In this particular case, the program was written to take the input and just do the same thing on the output. So I can take my sensor and activate it with my hand, because this is a capacitive sensor, remember, and capacitive sensors can be activated by pretty much anything: metal, paper, plastic, water, a lot of different materials. And this sensor has an adjustment on the back, so you can adjust the sensitivity of this one. This one has a range of 1 to 25 millimeters. So that's the proper connection to test the sensor and test the connection to the PLC. Remember, the sensor itself has its own way of showing you that it's sensing something. So we have 3 different ways, 3 different indicator lights here that tell us what's going on. If the indicator light for the sensor didn't come on, then that would tell us that there was something wrong with the sensor. If the indicator light for the input card didn't come on, that would tell us that we possibly have a connection issue from the sensor to the input card. And if the output indicator light doesn't come on for this particular program, then that means that there's something wrong with the program. Okay, next we're going to look at a connection diagram for the syncing sensor, and this is a inductive sensor that I mentioned earlier. So here's our inductive sensor, and this is a NPN sensor. So here's our diagram for the sensor and the input card. As we did earlier, the output card needs to be hooked to the input of the input card. And because this input card can handle syncing or sourcing, we can go ahead and make that connection. And that's going to, by the way, that output is going to ground when this switch, which is an NPN transistor, when this switch closes, we are introducing the output to ground. So we want this to go into our input like this. And then the question is, where does the common need to go? And in order to have a complete circuit from ground or V minus through the input card, we need to go to V+. So our connection here is simply going to be like this. So when the sensor activates and closes this NPN transistor, it provides a path from ground through our optical isolator and up to V+. Now, because of the connection here, the LED that's going to light up in this case is going to be this LED. So there's two LEDs in the optical isolator. They're hooked up in what we call a bipolar configuration, which means one LED will come on no matter how the polarity is connected to the LEDs. And as long as we have an LED coming on, we can activate the phototransistor in the optical isolator and we can activate the card. So this is the connection we're going to need to follow. Remember, the common in this case has to go to V+. For the NPN sensor, our common needs to go to V+, and our output goes to the input. So let's go ahead and wire that up and see how it works. On the capacitive sensor, I went ahead and hooked it up ahead of time to save time, but here I'll just show you what I'm doing here. You can pull the terminal block out of here, and I'm putting the black wire on the input, and as we said earlier, the common in this case needs to be hooked to V+. So we're going to hook the common wire in here, and I'm leaving a little piece of wire to be able to hook my V+. So I've got a little piece of copper wire sticking out of there, and my V- in this case is just going to be hooked directly to the battery. So I'm going to plug this in and hook up my power. So remember, we said that V- goes straight to the battery, and our common is, I'm going to try to get this out of the way so you can see it. Our common is going to V+. So if everything's hooked up correctly, we should be able to trigger the sensor with a piece of metal. So here we have a little stepper motor, and if I bring that close to the inductive sensor, we can see that the output of the PLC lights up and the input lights up, and also the sensor itself lights up. So this is a good connection. This is what we need to be able to do. As far as being able to troubleshoot a problem, if our light didn't come on, that would be an indication we had trouble with the sensor. If the input light didn't come on, then that would be an indication that we don't have a proper connection between the sensor and the input. And if our output light didn't come on in this case, then we know that there's something wrong with the PLC program. It's not telling the output to turn on and off when the sensor is activated. So I hope this was useful. Let me know if you got any questions or comments, and we'll see you next time.